Hi everyone, Assalamualaikum. In this video, we will continue with example 6b for Newton's law of cooling and the applications of first order ODE. A detective found a dead body at 8 p.m. The temperature of the body at that time was 30 degrees Celsius. 2 hours later, the temperature of the body dropped to 28 degrees Celsius. If the temperature of the room is 20 degrees Celsius and assuming that the body temperature of the person before that is 36.5 degrees Celsius, at what time did the murder occur? Right? To solve this problem, first, we need to extract all the information. Okay? From the information in the question given, we extract time for T and temperature for capital letter of T. Right? So we extract this. Okay? Time and temperature of room. Right? Now we check one by one. Okay? Right, found a dead body at 8 p.m. Okay? So, at 8 p.m., we assume T equals to 0. Okay? And then, the temperature of the body equals to 30 degrees Celsius. Right? And then, 2 hours later, okay? So, we can write T equals to 2 hours here. And then 2 hours later means 10 p.m. The temperature of the body equals to 28 degrees Celsius. Okay. If the temperature of the room is 20 degrees Celsius, so we can write Tm equals to 20 degrees Celsius. Okay. This is the temperature of room or surrounding. Right. And then the temperature before that is 36.5 degrees Celsius. So we can write this. What time did the murder occur? So T equals to question mark. Okay. This is time of death. Right. Right after that, we reorder based on descending values. Okay. Because when he dies, his body temperature will drop. Alright. So we reorder based on descending values. Alright. T equals to 0 at 8 p.m. Okay. T equals to 2 hours at 10 p.m. Okay. T equals to question mark means what time did the murder occur? This is time of death. Alright. Alright, we will get T equals to negative value because the time of death must be before 8 p.m. Right? So before 0 means negative. Right? And then just pass away, so the body temperature is considered to be the same as normal human body temperature. Right? From the previous slide, after we reorder based on descending value of temperature here, so we get this, right? And then from D temperature over D time equals to K times T minus Tm. Okay? Separating variables, time and temperature. Okay? So after we separate, we get this. Okay? We move over D time to right hand side. Okay? So we get times D time. Okay? We move temperature minus temperature of room to left hand side. So we get 1 over temperature minus temperature of room. Right? After that, integrating both sides. Okay, from here, we just put integration sign for both sides, right? And we integrate left-hand side and right-hand side. Okay, to integrate left-hand side, we can refer from, let's say we want to integrate 1 over x plus 2 dx. Okay, after we use u substitution, the answer equals to ln modulus x plus 2 plus c. Okay, if we use u substitution, we choose u equals to denominator x plus 2. Okay, or we can use the concept of if we have numerator equals to derivative of denominator, so after we integrate, the answer must equals to ln modulus denominator. Okay, and then plus c. So now we have integration of 1 over temperature minus constant, which is temperature of room, and then the temperature. So after we integrate using this technique, the answer equals to ln temperature minus temperature of room. Okay, and then plus c, but we just put plus c on one side only. And then equals to integrate right-hand side, we can refer this. Okay, let's say we want to integrate constant 2 with respect to x. The answer equals to 2x plus c. Now we want to integrate constant k with respect to variable t. So we get constant k t plus c after we integrate. And after we integrate, no more integration sign. Alright? Alright, after that, we want to write temperature as a subject. So first, we need to move ln to right-hand side. Okay? After we move ln to right-hand side, so we get temperature minus temperature of room equals to E. Okay? After we move ln to right-hand side, we get index base E here. And then to the power of KT plus C. Right? Alright, then we can write T minus Tm equals to E to the power of KT times E to the power of C. Okay? From A to the power of M times A to the power of N, using the properties of indices, we can write equals to A to the power of M plus N. So from here, if we have E to the power of KT plus C, we can split to E to the power of KT times E to the power of C. Right? Right. After that, we can write T minus Tm equals to C E to the power of KT. E to the power of C equals to constant. So we can write E to the power of C equals to C. Okay, because E here means Euler number, which is equals to 2.718 something, which is constant. And constant to the power of constant will equals to constant. So we just write E to the power of C equals to C only. Okay, that's why we get T minus Tm equals to C E to the power of KT. Right? Right, so from here, E to the power of C, we write equals to C. Okay, because E equals to 2.718 something equals to constant, to the power of constant will equals to constant. Okay. Right, after that, we can write temperature as a subject equals to, we move negative Tm to right hand side, so we get positive Tm, and then plus Ce to the power of Kt. Okay. From the previous slide, we get T equals to Tm plus Ce to the power of Kt. Okay. Okay, after that, we can write T equals to 20 plus Ce to the power of Kt. Okay. We replace Tm equals to 20 degrees Celsius here. Okay. So we get this. Okay. After that, we can name as equation 1. Right? Alright. After that, we substitute T0, temperature equals to 30 degrees Celsius, into equation 1 here to find C. Okay, and we use this information to find K, right? So to find C, substitute T equals to 0, temperature equals to 30 degrees Celsius into equation 1 here. Okay, so from equation 1, T equals to 20 plus C e to the power of KT. So we get temperature, we replace by 30 equals to 20 plus C e to the power of 0. Okay, we replace T equals to 0 into T here. Then we get 0 times K equals to 0, right? And then we replace temperature equals to 30 degrees Celsius into here. So we get this, right? Then e to the power of 0 equals to 1. Okay? So we get C equals to 30 minus 20. So C equals to 10. Right? After that, we substitute the value of C into equation 1. Okay? So after we substitute, we get this. Okay? We substitute C equals to 10 into C from equation 1. So we get this. Right? After that, we name as equation 2. Right? Then we use this information. To find K, substitute T equals to 2 hours and temperature equals to 28 degrees Celsius into equation 2, into the latest equation. Alright? So from equation 2, we have T equals to 20 plus 10 e to the power of KT. Okay? Now we replace T by 2 hours here. Okay? And then we replace temperature equals to 28, right? So we get 10 e to the power of 2k equals to 28 minus 20 equals to 8, right? And then e to the power of 2k equals to 8 over 10, okay? And then we can move e to right hand side because now we want to find k. Okay, so when we move e to right hand side, so we get this. Okay, 2k equals to ln. Okay, and then 8 over 10 equals to 0.8. Alright, and then using calculator we get k equals to ln 0.8 over 2, which is equals to negative 0.11157. Okay, we get K negative value. Okay, because we use Newton's law of cooling. Cooling here means the temperature will drop. That's why we get K in negative value. Alright. Right, after that, we substitute the value of K into equation 2. Okay, so after we substitute, we get this. Okay, we substitute K equals to negative 0.11157 into K in equation 2. So we get this, right? So now we have temperature equals to 20 plus 10 e to the power of negative 0.11157 T. This is the temperature at any time T, right? And after that, we can name as equation 3. Okay? Equation 1, 2, and 3 actually are the same equation. But equation 1, we write in terms of C and K. Equation 2, after we substitute the value of C. And equation 3, after we substitute the values of C and K. Right? From the previous slide, we get an expression for the temperature at any time T is given by temperature equals to 20 plus 10 e to the power of negative 0.11157 T, and we name as equation 3. Okay, Then we can use this information and we substitute into equation 3, right? Substitute temperature equals to 36.5 degrees Celsius into equation 3. Okay, so from equation 3 here, we replace temperature equals to 36.5. So we get this, right? After that, we move positive 20 to left hand side. So we get 36.5 minus 20 equals to 10e to the power of negative 0.11157 t. Okay. Then we have e to the power of negative 0.11157 t equals to 36.5 minus 20 equals to 16.5, and then times 10. When we move to left hand side, we get over 10, right? Right now, we want to write t as a subject because we want to find t. And t here in exponent. So we need to move e to right hand side. Okay, so when we move t to right hand side, we get negative 0.11157 t equals to ln. Okay, and then 16.5 over 10 equals to 1.65. Alright. Then using calculator, t equals to ln 1.65 over negative 0.11157. So we get this. Okay, t equals to negative 4.48844. Okay, since the given unit for time is hours here, so we put hours. Alright. Right now we have time in decimal value. So we need to convert the decimal value here in hours and minute. Okay, to find the time of death. Alright. Right, so from t equals to negative 4.488 for 4 hours, to convert into hours and minute, we can split whole number for hours and then plus decimal number 0.48844, we multiply by 60 minutes because 1 hour equals to 60 minutes. Okay, then we get this. Okay, t equals to negative 4 hours plus 29.3 minutes. Okay, after that we can convert 0.3 to second. Okay, or in this case, let's say we just put in minute only. So we write t equals to negative 4 hours. We approximate 29.3 minutes equals to 29 minutes. Alright. So we can find the time of death. Okay, equals to 8 p.m. Okay, minus 4 hours 29 minutes means 8 p.m. minus 4:29. Okay, so to get this from 8 p.m. okay, we write into the form of 760. Okay, and then minus 4:29. So after we subtract, so we get this. Alright. Alright, then we can write, thus the murder occurred 4.48844 hours before 8 p.m. Okay, means 4.48844 hours. We approximate to 4 hours 29 minutes. So the murder occurred at about 3:31 p.m. Alright, this is the final answer. What time did the murder occur? So the murder occurred at about 3:31 p.m. Okay, the same day because t here less than 12 hours. Alright. Coming up next, mixing problems, which is applications for linear differential equations. If you like this video, we can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.